Okay, so this is a weird one. At this point, quite a few of these episodes have focused on the pseudonymous authors of clandestine chemistry manuals from the golden age of psychedelic chemistry in the 60s and 70s. I have tracked down quite a few of them, but there was one book that I was fascinated by for a number of reasons. One was that I just couldn't find it. It was called The Alchemist by Tarik Peterson. It was mentioned in a couple of places, but as far as I could tell, a copy of it had never been sold. No one seemed to know how to find it or where to find it. I tracked down, as far as I know, the only copy in existence, which is at Harvard, had it digitized, and I was delighted to find that it was as good as I hoped. It was unusually sophisticated, not just photocopies of patent literature or something like that. It was clearly written by somebody who had personal experience with the chemistry, and it was extremely comprehensive in its scope, covering everything from cannabinoids to lysergamides to tryptamines, phenethylamines, and even anticholinergics. Additionally, it had the cost in dollars of all of the different chemicals in 1970, which is always cool to see. It showed an extremely tedious 5-step synthesis of mescaline starting from gallic acid. And it had all kinds of weird folk toxicology stuff, like the idea that the psychedelic poisonings at Woodstock were potentially caused by an unreduced 3,4,5 trimethoxy benzonitrile impurity, or even more bizarrely, that some batches of cannabis were contaminated with a chemical called benzyl diethylamino benzoate. And I looked up the structure of the compound that he presents in this book. It is totally unknown. So outside of this one reference to this chemical, it is not referenced anywhere else, and I actually don't know what he's referring to. But even that's weird. And that just goes to show, again, how at that time, who knows where this came from, but this is the sort of thing that could very easily become a meme that would circulate in the underground drug community. And I love these books because they provide so much historical insight. It's very easy for somebody to look at them and say, oh, well, I only look at scientific literature, or to kind of diminish the importance of these texts. But they are such an important insight into scientific understanding in the underground during that period. This is where people were getting their information. If you want to trace the history of things like the bizarre idea that you could get high from bananas, you can trace that to these types of books. These were the trusted source of information in an era before the internet, before forums, before any of this. I started trying to figure out who Tarik Peterson was. At first, I assumed that, like most of these books, it was a fake name. But there was something different about Tarik Peterson, and that was that there was a scientist named Tarik Peterson who'd authored a number of peer-reviewed scientific publications on denitrifying bacteria that produce siderophores containing an oxazolene ring. Additionally, and perhaps more provocatively, these scientific publications were co-authored with none other than Joe Nealons, a legendary biochemistry professor at Berkeley. He is perhaps best known as being the doctoral advisor of the Nobel laureate Kary Mullis, and a permissive advisor because apparently he knew that Kary Mullis was synthesizing LSD and using various psychedelics that he had been making. Additionally, Joe Nealons had influenced the great journalist Seymour Hersh in informing him about essentially war crimes that were being committed in Vietnam. And there was something weird going on. I was basically thinking like a conspiracy theorist, to be honest, which is like, what is going on? What are the chances that this one prominent professor at Berkeley was advising two different psychedelic chemists, both of whom synthesized DET and used it and seemed to think of it favorably. It just seemed like a really weird coincidence. Joe Nealons, the scientist and anti-war activist, was he collaborating with the psychedelic underground to introduce DET to influence the anti-war movement? As it turns out, it doesn't seem that is the case. It is just a really weird coincidence. And for anyone that hasn't read Kary Mullis's autobiography, there's an entire section dedicated to him synthesizing DET and consuming an overdose so large that he essentially loses his entire identity. He doesn't know who he is or where he is, and it takes days for him to regain any semblance of normal consciousness. So, I don't know. I just thought there was something weird going on, and I would find these tantalizing little references to Tarik Peterson in different books. He would be thanked, but I could never find him. And when I reached out to people, it didn't go through. And then I decided I would just try again. Got through to him, and his story is really interesting. As I expected, he was writing from a perspective of personal experience making these psychedelics. And he wrote this book when he was a teenager in 1970. He's now retired and in his 70s and seemingly has not done anything related to psychedelic chemistry in many years, but his memories of that period are vivid, and at various points in the conversation, he describes synthesizing DMT, DET, 5-MeO-DMT, AMT, pyrrolidine tryptamine, TMA, TMA2, TMA6, mescaline, and MDA. So he's kind of speaking modestly like he didn't do all that much, but it sounds like he did virtually all of this as an undergrad at Antioch College with an advisor who was so excited that there were students interested in chemistry at all that he encouraged him to make all of these drugs. He also discusses meeting with Alexander Shulgin to propose the idea of synthesizing conformationally constrained phenethylamines that would best be described as 3-aminochromanes. These would be amphetamines, essentially, where the methoxy group in the 2 position shares a carbon with the alpha methyl carbon. And what's kind of amazing to me is this is a very simple idea. The chemistry is probably challenging, but certainly not impossible. And nobody has done it yet. People have made a number of related compounds that appear to have significant biological activity as melatonin receptor agonists, as dopamine agonists, and even ambiguously as serotonin agonists in one paper by Richard Glennon. But nobody has done exactly what Tarik Peterson was proposing to Alexander Shulgin. And those would be interesting compounds to make. It's kind of amazing how much remains unsynthesized even today. This conversation ebbs and flows. He starts telling stories about his psychedelic experiences toward the end of the conversation. At the beginning, I think he's a little bit more reserved, and that's understandable. I mean, apparently, he thought he was writing this book under a pseudonym, The Alchemist, and then they published it as The Alchemist by Tarik Peterson. So he was not someone who ever wanted his name attached to this to begin with, but it was, and apparently the book was not read by all that many people, and so nobody has ever contacted him about it before. It would have been very easy for him to say, that was a long time ago, I don't want to talk about it, but instead he told me the story of his life in chemistry, his experiences with these compounds, and what it was like doing this sort of work in the 1960s and 70s. I think it's a fascinating conversation that ranges from his attempted recruitment for a bizarre procaine distribution ring to his attempts to make nitropropenes from the phenylpropene and tetranitromethane. This is a really old way of making nitropropenes that nobody seems to do anymore, to his experiences with PMA and finding PMA derivatives in Joe Nealon's lab and meeting Carrie Mullis and lots of weird stuff. So it's a good conversation, and he gave me permission to share the PDF of his book, The Alchemist, which will be attached to this interview along with a number of scientific papers that elaborate on some of the things that we discussed. This is an interesting conversation. I've got some good stuff coming out soon. The interview with Mike Cunningham will be released in a few days. And I hope you enjoy this discussion with Dr. Tarik Peterson. For as long as it has existed, the market for street drugs, supplements, and even pharmaceutical products has been marked by uncertainty regarding chemical identity and purity. Colorimetric reagents and repurposed urine test strips offer some protection, but they are no substitute for analytical techniques like mass spectrometry. In the United States, drug testing is fraught with bureaucratic hurdles, but in Spain, scientists are free to perform chemical analysis without legal interference. I've recently partnered with a Barcelona-based laboratory called Kykeon Analytics, who offer NMR, FTIR, and LCMS-MS for any plants or chemicals one might wish to analyze. I submitted a few samples and was impressed by their ability to detect a psilocin ester in a gummy product, an unusual modafinil analog with precise structural assignments, and a diphenhydramine analog. Samples can be sent anonymously from anywhere in the world, and the pricing is extraordinary for the service they provide. Additionally, Kykeon performs their own analyses of new psychoactive substances and freely publishes their results on their website for educational and harm reduction purposes. To learn more, go to kykeonanalytics.com. Okay, thank you so much for calling me. I've actually been trying to find you for years, but I think I've just been going about it the wrong way.
Oh, well, when I tried to get my email address, I found that there are half a dozen Tarik Petersons in the United States, but I think I'm the only white guy.
It's pronounced Tarek?
Yeah.
Got it.
That's the Turkish way. I'm not Turkish, but my namesake was.
I tried contacting someone named Nathaniel Hellerstein because he thanked you in a book called Diamond, A Paradox Logic, but he never responded to me.
Yes. He's a math professor and a friend of mine.
I see. I am very interested in the history of clandestine chemistry, and I collect these books that were published in the 60s and 70s that were oriented toward teaching people about how to produce various psychedelics. And I think that they're very important because, of course, in the era before the internet, this was a really valuable way to disseminate information. But as you know, the reality is that most of these books were of limited value. They were kind of almost more novelties than anything else. And some of them even promoted potentially dangerous information or misinformation about things like banana-derived hallucinogens. And when I found your book, I was really blown away because it was so comprehensive, so technically precise, and it appeared that you were writing from a perspective of personal experience with a lot of the chemistry that you were describing. And I started looking into you a little bit. I found the paper that you co-authored with Joe Nealon's about bacterial siderophores containing an oxazoline ring, but couldn't find all that much else. And so it was just this mysterious book. Like, who is this guy and what's his story?
Well, I was a college student.
Right.
I was 19 or 20 years old.
Oh, wow.
When I wrote that.
That's even more impressive.
The Nealon's lab came later. I was 30 by the time I got my PhD.
Got it. So This is especially impressive given how young you were. This is published in 1970. And what motivated you to create it?
Well, I was asked to. What happened was, when I was in high school, LSD hit the news. It was in the newspapers a couple times a week. There'd be an LSD article. And I wasn't really into drugs, but I was in high school, and it's something high school kids talked about. So they knew I was good in chemistry. They kept coming to me and asking. I said, well, a chemist ought to know about these things. So I hit the books. And none of us had any kind of, college education yet. And so we were kind of clueless. I remember a friend of mine went to the University of Washington. It's in Seattle. And he says, I found a paper on how to make mescaline, but it's in German. None of us knew German. So if you know enough chemistry, you can sort of make out what the German words are. They're not that different. And I looked at it, and he said, this paper shows you 7 ways to make mescaline. I thought, well, that's weird. And when I read, I realized that what it was there are 7 steps that you have to go through. Not 7 different ways to make mescaline, but 7 steps you have to carry out to do it. And we didn't have any laboratory or anything like that. So the next year, I was off in college, and I had the access to the libraries. And so I started looking things up in, the Journal of American Chemical Society and all of these things. And it turns out that information was readily available. And so by hitting the books and finding papers and Xeroxing them, I made a bunch of notes, and I got interested in what they call the structure-activity relationships, where you have a lot of molecules that are more or less similar, but they have slightly different pharmaceutical effects and different dosages. And I ran across Shulgin's work with the methoxyamphetamines. And there are 6 of them, and he made all of them, and they all have different doses and things like that. And as I was in college, I noticed that a lot of people were interested in it, but they didn't have the time to go to the library and dig all the stuff up. They didn't know that. And I had already Xeroxed and made my copies. And at one point, so I was handing out basically technical information to people because they were making mistakes. They were saying things that just weren't so. So I'd hand them the paper and say, look, this is the way it is. And at one point, I was approached by a fellow who said, you really ought to write this up and I'll publish it. We'll make some money. And I thought about it. I said, maybe I'll do it, but I should be anonymous. And so I decided that I would be the Alchemist, and I put that on the title. Well, the guy, what was his company? I think it was called Turn-Ons Unlimited or something like that.
Yep. Yeah.
He was into selling books on this stuff, and so I typed up my notes, and it's basically a photocopy of what I typed. All that was done on a typewriter and with pen and ink. And so I sent off the manuscript to him, and damn if he didn't put my name on it. I didn't intend that. But he sent me one copy of it, and I think I might have gotten a check for like $18 or something. It was not a financial success, this publication, shall we say.
Huh.
I don't know how many copies were printed, I never heard from the guy again.
And on the book, it says edited by Gary W. Clausen. Is this the guy?
I guess so. I've forgotten the name. That's right. I didn't write that part, and I didn't write the appeal for people to send in stuff that's sort of in handwriting on the last page. That must have happened after my copy got sent to me. I'm not sure I even have a copy at this point. So thanks for sending me the PDF. It helped. It helped me remember what it was all about.
And did he appreciate what you had given him? How sophisticated and good it was?
I think so, but he wasn't a chemist.
Right. And so you wrote this book. You don't know how many copies were sold, and that was the end of it, or what was nothing?
No, pretty much. That was the end of the book. Yeah, and that I never saw a copy in a store, or nobody ever came up and asked me, hey, did you really write this book or anything like that? But I did have a reputation for knowing about this stuff, and people asked me if I was what was that guy you interviewed? He took Heinlein's character's name.
Michael Valentine Smith.
Yeah. I've been asked, are you Michael Valentine Smith? I said, no, I'm not. So people did associate me with books, but never that one.
So I'm the first person that has contacted you about this.
I believe so, yes.
Oh, wow. That's sort of amazing.
I got another email, which I didn't respond to a few days before. I think you contacted Sarah Huff.
That's correct, yes.
By email, yeah. She sent me the screenshot, and but that was, I'd actually heard from another guy a few days prior. So I guess, did you just release that video?
Yes, that must be why.
Okay, well, somebody else took the initiative and found my email address and sent me an email with a link to the video, but I wasn't sure who he was, and I didn't respond to him. So you came in a couple of days later.
Got it. Okay.
These days, alternative cannabinoids or altnoids have become increasingly popular. You may have heard about THCP or THCV, but have you heard of THCB? The butyl. Over 86% pure THCB isolate. That's impressive. This was just a year or two ago, a trace oddity that people only speculated about. Now we're living in the future. You can get THCB on the internet. If you're listening to this right now, you can just order THCB. What a time to be alive. Can you imagine? You can just order the butyl THCB from CannaClear.com. Use the promo code Hamilton. You gotta cherish these moments while they last, because one day you're gonna wake up and the government is gonna have decided to protect you from THCB. They're gonna step in to save you from THCB.
I find the ways that people historically made psychoactive drugs and the way that it's evolved very interesting. Even looking at the synthesis that you present for mescaline, which is a 5-step synthesis starting from gallic acid. I mean, it seems like quite a hassle compared to the...
Well, yes, and it turns out there were a lot of problems with that. It's a very strange story. There was some college bull session, and somebody said something like, I wish I could make some mescaline. And I said, well, I've got the recipe, and I gave him a Xerox copy. And a couple of days later, he came back, and he says, I took the paper over to the chemistry department and told the chemistry professor that I wanted to make some mescaline. And he was really excited about it. And he said he knew some guy who might help me do it. This was like my second year in that college, your second quarter at least. And I said, oh, well, that's interesting. I'd like to meet this guy. And so later that day, I was wandering over to the chemistry department, and I see one of the chemistry professors walking in the other direction. And all of a sudden, I got the impression that I might be that guy. And sure enough, as we met, right away, he says, oh, Tarek, I've been looking for you. How would you like to make some mescaline? And I didn't know quite what to say. I said, well, Professor, what's this all about? He says, well, there's this student who's interested in it, and I'm hoping he will become a chemistry major. So could you help him do that? I said, okay, yeah, I think so. I'll think about it. And so the backstory on this is that at that college, it was the 60s, and there was this big anti-science movement. They didn't have any chemistry majors. They were really glad that I was there, and they were really searching for chemistry majors. So that was what was on the professor's mind when the student made his proposal to him. We get more chemistry majors this way. That's good. One of the amazing things about those days was how clueless the adults were. Kids were coming to high school on LSD. The teachers didn't notice. This is even true of the researchers. LSD was synthesized in 1938, and its effects were discovered 5 years later in 1943. And so all through the rest of the 40s and part of the 50s, they were studying it, and they called it a psychotomimetic because they believed that it mimicked the effects of a schizophrenic break, a psychosis.
Right.
But most of these people who were studying it, they never took it. Okay, at least not in this country. And so they were kind of clueless about the effects, and they couldn't see it happening all around them. So this professor was similarly sort of clueless. I think he assumed, probably correctly, that mescaline was not illegal to make at the time, because at that time, I think LSD had just been made illegal. It was like in 1969, I think, they finally passed a law against it. There wasn't any law against these drugs. They were sort of unknown to the authorities. So pretty quick, we find out that this kid who contacted the professor, he's not interested in making it himself. He wants somebody else to make it. He'll sell it. That was his plan. So it never turned out to. The professor never got his other chemistry student, but I wound up with a pound of gallic acid, which he ordered for this, and he said, "Oh yeah, go ahead. Go ahead. You want to do it? Go ahead and do it." So you're right. It's a long synthesis. If you have a good supply of lithium aluminum hydride, it's not that hard to do. But the lab I was in was a fully equipped lab with nobody using it. So I had the run of the lab, fully equipped with all chemicals and all sorts of things, and professors that were okay with it. And so I ran into trouble because the next to the last step is it doesn't work the way the literature says. That yield in the Alchemist is probably way better than it actually is. And I never did get enough to actually consume. Okay, the yield, multiple steps, the yields are poor, and the last step used up all of the stuff that I had made an investment in, and I think I got something like half a gram of the material, which if I had processed it one more step would have made mescaline, but half a gram of mescaline is just a single hit. So I never did.
So you only took it to the trimethoxybenzyl cyanide step.
Right. The chloride to the cyanide. It turns out you should use a solvent like DMF or DMSO, not ethanol. Cyanides need to be in an aprotic solvent in order to be active, and I didn't know that at the time. I mean, I wasn't getting any mentoring here. This is just, my own efforts.
I find this interesting on many levels, even just that you said in passing that you felt there was an anti-science movement in the 1960s. I'm not familiar with what you're describing.
Oh, well, it was the war. The scientists were, they built the bomb. And the Vietnam War, was in the news every day, how many commies they had blown up, on the evening news. And so, a lot of the students were anti-war. I didn't want to be drafted. And I thought the war was useless. And a lot of people took it further. And they didn't want to have anything to do with the industrial society that led to the war, or so they thought. And so nobody was interested in going into science and engineering. The school actually lost the accreditation for its engineering department, and they shuttered it and put all the stuff in a storeroom and had no engineering department for lack of interest in the student body.
Wow, what school was this?
It was Antioch College in Yellow Springs, Ohio, which has since gone out of business and then been resurrected under the same name, but it's somewhat different now. But by the time I finished, the pre-med explosion had happened. All these students realized they could make good money by becoming doctors, and all of a sudden, everybody was taking a chemistry class. So by my last year, I was the TA for, 30, 35 people in a chemistry lab, whereas when I had gone through, it was 2 people, me and one other guy.
This podcast is also brought to you by Lucy Nicotine, a company that makes nicotine pouches, nicotine gum, and nicotine lozenges. I particularly enjoy the apple ice flavored nicotine pouch. It is a refreshing and well-formulated product. If you don't already use nicotine products, I recommend you don't begin. They're habit forming. But if you do, I think this is the finest nicotine product on the market. Thank you, Lucy. And in case this isn't already obvious, warning, this product contains nicotine. Nicotine is an addictive chemical. I mean, that's still very often the case. When I took organic chemistry, I think I was the only student in the class that wasn't pre-med.
Yeah, it's the bread and butter of the chemistry department.
And so at the time that you attempted this first mescaline synthesis, did you have any previous experience with organic synthesis or making psychoactive drugs, or was this your first synthesis?
Oh no. This is when I was doing my independent study in organic chemistry. It was the first time. It went on for about a year.
So the first molecule that you attempted to synthesize was mescaline?
Yeah.
Oh, wow.
That's right. Actually, it was the aldehyde, nitrostyrene, and reduction. That was the one that we used that which finally worked.
Right. I mean, that's the only way that people tend to make phenethylamines anymore is with the Henry reaction between the aldehyde and the nitroalkane.
Yes. We went on to try some other things besides 3,4,5 and using the nitroethane to get the amphetamine instead of the phenethylamine. And we found that each one is very different. The solubilities are very different. It made the yields very different. But it is a general way of doing these things.
And so you successfully synthesized TMA as well.
let's see. Yeah, 3 of the TMAs, PMA, what else? Alpha-methyltryptamine, and then a couple of the DMT and DET, and the methoxy-DMT.
5-methoxy-DMT.
Yeah, the 5-methoxy-DMT.
And was this all above ground academic work because they were just excited that you were excited about chemistry, or had you transitioned this into a private lab?
No. This was all in the chemistry labs. Their only complaint was we used up too much ether.
It remains a complaint today. Ether is still horrendously expensive. So that must have been a lot of fun. And am I correct in understanding that these compounds were not controlled during the years that you were doing this research?
Yes, that's right. Back then, they didn't think that they could ban a whole class of compounds. In order to get a conviction, they would have to have the compounds named individually in the law. And so every time somebody came up with another isomer, they would have to pass another law and add it to the list. And therefore, there are an awful lot of them who hadn't had that happen yet.
Right. And I'm always fascinated by how many people get interested in chemistry as a result of their fascination with psychoactive drugs. I think for some people, they see it as, that's not a good path to go down, or, it's dangerous. And obviously there are people like the friend or the acquaintance that you described that are merely interested insofar as they can sell whatever they make and make some money off of it. But I think that the scenario that you describe is a lot more common than people realize, that people get interested in the synthesis because the compounds that they're synthesizing are so fascinating.
Well, yes. And also, I'm the Sputnik generation. I was in the first grade when Sputnik went up. And so we were raised to be scientists. And we had a can-do attitude. So all it took was one article where it said, this LSD is relatively easy to make. That gave an awful lot of high school kids ideas. And of course, we weren't at all prepared to move forward on them, being massively ignorant. But the interest was there. Nobody thought it was odd that we would decide to make our own pills.
And you were also from a generation where the understanding of the natural occurrence of these things was far more limited. I'm always amazed.
Well, yes, we were just discovering that. And then, of course, that was a big thing, too, because, the hippies, they respected the Indians. And when they heard that the Indians knew about peyote and mushrooms, that just confirmed the way they were going anyway. And it was, for a lot of people, it was much more of a spiritual quest than a let's get high and party kind of thing.
Right.
So, and of course, that's what the Indians would say.
Right. But what I'm referring to even more specifically is in your book, you say this, and this was a common belief at the time, that, you can only find psilocybin containing mushrooms in Mexico, right? People didn't know that psilocybin containing mushrooms grow across the United States, that DMT could only be sourced from rare South American plants, that most of these things were not available unless you were a chemist and you synthesized them, that this was not a choice, but a necessity. If you wanted to access these compounds, you had to learn chemistry and make them. Otherwise, you're not going to get DMT.
That's right. Yeah, that's right. South America's a long way away.
Whereas today, if a young person is interested in DMT, they extract it from Mimosa hostilis root bark or a related plant. If they're interested in psilocybin, they grow psilocybin-containing mushrooms or they pick them locally. If they're interested in mescaline, typically they grow San Pedro. And the result of this increased availability of naturally occurring psychedelics has been a de-emphasis of the synthetic world.
Well, yes. When there's a plant source, it's always easier and cheaper than trying to do it in the laboratory.
Exactly. But I think that there's something ever so slightly tragic about that, because it prevents young people sometimes from going on this path of learning the chemistry because they're interested in the products of that chemistry.
Mm-hmm. That's right. Better living through chemistry was an advertising slogan at the time, and the hippies adopted it right away.
And so you're making all of these compounds, and I assume that you conducted a few self-experiments.
Oh, yes. I mean, the total amount made is an order of a few grams of each one. So, there wasn't that much to play with. But yes, a lot of my fellow students and I would spend an afternoon testing out one or the other, and there are a bunch of wild stories about that too.
Well, that must have been a lot of fun. I mean, using a psychedelic under any circumstances can be an immensely rewarding experience, but using a psychedelic that is the product of this dedication of learning the chemistry and executing the synthesis and knowing that you created it yourself and that it's pure adds an additional layer of appreciation.
Oh, yes, that's right. Yeah.
So could you tell me a little bit about what that felt like, trying mescaline that you had synthesized?
I'll tell you the bad news first. Most of those are actually rather boring. I mean, compared to LSD, mescaline, and say DMT, those there'll be a lot of visuals, a lot of meditation, thought-provoking things and stuff like that. But the others, I don't know, they didn't interest me as much. Okay, and I've seen later people talk about various ones, and there's one guy, or maybe it was the Valentine fellow. He said that TMA was very interesting, and unfortunately, it's bad for your heart. You should stay away. But he thought it was very interesting, and we thought that was the most boring one of them all. We could sort of tell that something physical was going on, but it wasn't particularly psychedelic, shall we say?
Right.
One more I should mention is MDA. We made a little bit of MDA, and that was a big hit, even though it's not visual at all. But everybody sat around and started talking. And they had this very intimate conversation. And after about an hour and a half, one of them looked up and he looked at me and he said, "This stuff is really good." And he says, "I'm not seeing anything," but they were very interested in it. Unfortunately, it's really rough on your body. I mean, the next day you're tired, and it's, I don't know, the amphetamines, well, they're amphetamines, and then they have the problem of amphetamines, physical side effects, heart rate issues, things like that.
This podcast is also brought to you by Matcha.com. Grab a traditional matcha bowl or your favorite mug and enjoy a hot cup of matcha first thing in the morning. I don't drink coffee, but I think matcha is a wonderful way to start the day. It contains L-theanine, it contains caffeine, which is what I'm most interested in, and it has all sorts of purported health benefits. Matcha.com was founded by psychedelic pioneer Dr. Andrew Weil. All of their matcha is imported from Japan and third-party tested for heavy metals. It's delicious, probably healthy, and certainly stimulating. So enjoy a cup of matcha from matcha.com. And this is, of course, before people recognize the value of MDMA.
That's right. That's right. We hadn't heard of it.
And in your book, you do seem to suggest that you thought DET had advantages over DMT, but it sounds like now you're...
A lot of people preferred it. I don't know, it's not that intense, but I think they liked it because it lasted a long time. The DMT was over too quick for them. And in that book, I realized I was worried about the methyl groups coming off and making methyl alcohol. And I was thinking that might be a health problem. I suspect that's not correct. I think when they take a methyl group off, it doesn't necessarily produce methyl alcohol. That's what folic acid is for, is to handle those single carbon moieties.
And even if it does, it would be such a minuscule amount. I mean, there's so many N-methyl groups, even in caffeine. Yeah. I don't think that N-methylation poses a toxicological risk, but I thought that was a really interesting example of the kind of folk toxicology that was circulating during that era, because there were no internet forums, there was no way for people to really vet a lot of this information. And now DMT is considered, the spirit molecule. It's natural, it's good, it has all sorts of positive associations that may or may not have any scientific truth behind them, but people typically believe that it is produced during near-death experiences and birth and death and so on and so forth. But what is fascinating is to look back to the 1960s and see that DMT and DET were regarded with some degree of fear. People thought that they might be toxic.
Well, I don't know. I don't know how many other people were thinking of that. That was sort of my own warning. I wanted to make sure I put some cautionary material in that book.
You may have been the only person to specify the potential for toxic metabolites, but you were certainly not the only person to voice some concern related to it. I mean, I've seen other things published during that era suggesting that DMT and DET might be dangerous and toxic. And I imagine a lot of that came from the uncertainty, because you didn't have a strong half century of global human use showing things like LSD doesn't cause chromosome damage or DMT doesn't cause brain damage. And it's always amazing for me to think about what it must have been like during that era when there was so much less information available to people.
Yeah. Well, when I look back on it, I saw so many people taking such incredible risks out of ignorance. It seemed like they weren't being very careful at all.
Well, you mentioned STP in your book. That also had a very negative reputation. Was that one of the ones that you made?
Well, yes, but you see, the reason why people gave those a bad reputation is because they were ODing on it. So, like these guys who think that DMT is going to help them meet the spirit world, as far as I can tell, they're taking huge, huge doses. Because they're describing things that none of my cohort ever ran into. With STP, the problem is that if you take enough that you have a lot of visuals and things, you're probably going to be up for 18, 24 hours. It's the time that the effects are around starts getting longer and longer. And in some of the early days, people were taking double hits, and it was lasting into the third day.
Right.
I mean, they might even be able to get some sleep, but the next day was different. and so on. So I think that's what made people worry. They said things like, I could tell my brain cells were exploding. Well, no, they're not, but they thought they were, and they worried.
Did you ever synthesize STP?
No.
And how were you administering the DMT? Were you smoking it?
Yes. We dissolved it in ether, spread it on a bunch of bunk pot, and smoked the pot.
And you were making the DMT via the Speeder-Anthony route, reacting the indole with oxalyl chloride?
Yes. Yes.
It's beautiful chemistry. Do you have any memories of doing those reactions?
Yeah. Yeah, I still remember those days. It's hard to clean up. When you get a lot of aluminum salts from the hydride, and you can't add acid to dissolve the aluminum because that will mess with the indoles. They're acid sensitive, and so it was difficult to purify, and if not completely purified, it's not stable. The crystals will turn red after a few days, and a few months later, it's pretty much gone. So there were problems. I imagine if I had known more about chromatography or something like that, it might have been different. I don't know what they're doing these days.
These days, people are almost exclusively extracting it from plants, but when it is synthesized, it seems the favored method is reductive amination of tryptamine.
Oh. With like what, formaldehyde and?
With formaldehyde and sodium borohydride.
Oh, okay. I thought you might get some cyclization on that.
You
get a harmala-like substance. But yeah,
you're absolutely.
If you did that right, that would probably work just fine.
Yeah, and you're absolutely right. By the way, the competing Pictet-Spengler cyclization is a problem if the reaction isn't sufficiently cooled.
Mm-hmm. The other way I've heard is you exhaustively methylate the tryptamine, and then you heat it up with some ethanolamine, and one methyl group comes off.
That's the way DMT was first synthesized by Richard Mansky, was thermal decomposition of the quaternary ammonium cation. So that's the first way it was ever produced. Yes,
and you can do this same kind of thermal decomposition with tryptophan and get your tryptamine.
Right.
So that's the one I'd recommend for somebody who's not really a chemist, doesn't want to mess with, expensive and hard to get reagents.
Right. The other really interesting little bit of folk toxicology in your book is the suggestion that there was poisonous mescaline being distributed at Woodstock that either contained a cyanide impurity or unreduced trimethoxybenzyl cyanide.
Was that in there? I didn't see it in the PDF.
It's in there, yeah.
Oh. Well, there were all kinds of rumors going around. There was the Tarek scare, and there was another scare before that, which I did see in the book there. They thought the government was putting some sort of additive to the pot to make people sick who smoked it. And I don't know if that was ever true.
It was. I mean, they certainly did spray a lot of cannabis with paraquat.
No, I'm talking about this other compound.
Oh, the benzyl
some sort of dimethyl-aminobenzene ring or something like that.
Right, yeah.
It's in there. But I don't remember where I heard about that.
If you're looking for a kratom product, allow me to recommend Top Tree Herbs and New Brew Kratom Kava Green Tea Seltzer. Both are third-party tested. These are pure products that I can personally recommend. New Brew is a delicious carbonated Kratom Kava green tea seltzer And if you're looking for a simple, tasty kratom tea, go for top tree herbs. This is your health. You should get something that's tested. You can get 15% off using the promo code Hamilton. Thank you, Top Tree Herbs and New Brew, for your sponsorship.
But there was this fear that the government was trying to poison drug users.
Yes. And there was a scam. The Paracut scare was largely a scam. A bunch of people talked it up as if it was very common, and then offered to test your marijuana to let you know if there was any paraquat in there. And people all over the country sent them a package of marijuana with a few bucks in it, and they told them, oh yeah, we found a little bit of paraquat in there. And that spread the fear, and they got more and more packages in the mail containing marijuana and money. They put the money in their pocket and the marijuana in their pipe, and they kept it going for a couple of years. So I'm not sure how much pot was actually contaminated with paraquat.
That's fine. I've never heard that before, that these drug testing services were scamming people. It's a funny idea.
Yeah, and that continued when cocaine became popular. There were these places where they would tell you, if your cocaine was good. And generally they would report that it was, but they tested it by putting it up their nose.
Uh-huh. And so you got a undergraduate degree in chemistry at Antioch, is that correct?
Yes.
And after that, what did you do?
Well, Antioch has a work-study program. So you spend half of your time on campus in Ohio and the other half in some other city working a temporary job. I think they call them internships now. Generally, the corporations would make a position for a student, and they understood that every 3 or 6 months the student would change. But they'd always have a student. And it was, a low-salary job, but you learned a lot. One of my jobs was at the public health department in Berkeley in air pollution. And I went out into the field and calibrated the air pollution monitoring machines and things like that. And I made up solutions for those machines when I wasn't out in the field. It was sort of a low-level job, but I heard a lot of things. You hear a lot of stories in the public health department. So when I graduated, I called them up and I said, "Hey, can I come to work for you?" And I did. I worked at the public health department there in Berkeley. It was the Air and Industrial Hygiene Laboratories. And while I was there, I decided to go to graduate school, so I applied to the Department of Biochemistry, which was across the street from the public health department, and got in there. And so there were like 2 years I wasn't in school between college and graduate school. But pretty quick, I was working in Joe Nealon's lab. And again, I was making small molecules, but this time they were these bacterial products that chelate iron, the siderophores. The quick story is that iron is so insoluble that bacteria have a hard time acquiring it, even though it's fairly common in the environment. And so they make a compound that will wrap around the iron and solubilize it, and then they pump the compound in. So they basically are sending out something to digest the iron, and then it diffuses back to the cell, it gets pumped in, and that's how the bacteria get their iron supply. And there are a lot of complications to this, but that's what I was doing in graduate school. And so that lasted to 1980. Then I tried to become a college professor, but that went south. Affirmative action basically did me in. Those were the years when they decided that not only did the student body have to match the racial makeup of the society at large, but the faculty did too. And so they had too many white guys, and there was no permanent job for me. So I bopped around as a sabbatical replacement for about 7 years, and then I got a job in industry and did that for a while. And now I tutor students, and that's much more rewarding, actually, than being a professor, interestingly enough.
What were you doing in industry?
I was writing software, and still am. I've still got the job. I'm sort of emeritus on the job, but I write software for chemists to take data from their gas chromatographs and print reports. It's a productivity tool.
Oh, wow. That's cool. And did you want to continue pursuing psychoactive compounds? I mean, you moved from Ohio to Berkeley in the 1970s at the center of the drug scene. It was probably a better time than ever to be interested in psychoactive drugs. You were close to Shulgin, but then you appeared to transition into this very serious biochemistry work that wasn't related to psychoactive drugs or psychopharmacology.
I was trying to get a standard PhD in a field that would get me a professor job. That's what it was. I wasn't, in a way, choosing Berkeley biochemistry might have been a bad move, because my boss told me, he said, Tarek, if you were going into research, I could set you up through my contacts with several laboratories, and I could get you a postdoc job and, launch you on a research path. He says, but I can't do that if you want to go into teaching, because I don't know anybody. Okay? And so I went there anyway, thinking that I was going to, be a teacher. I did a lot of teaching assistant stuff, more than I had to. And I was married at the time. And when I got my PhD, I moved down to Santa Barbara, waiting for my wife to graduate. And that took an awful long time. Eventually, the marriage went south. And I found myself thinking I ought to get on with my teaching job. And so I got another postdoc for a year and started applying to colleges. And that started my 7-year teaching adventures all over California, and a year here, a year there, never a permanent job. And eventually I got tired of moving every year and not having a job sometimes. So I moved back to the Bay Area, looked in industry, and that's where I've been ever since.
And you were teaching biochemistry or organic chemistry? What were you teaching?
I was teaching general chemistry, organic chemistry, and biochemistry, often to like nursing students, or what was the other one? Sports medicine. Those were big, popular majors when I was teaching. So most of my students were in one of those fields.
And did you ever talk about your past or use psychoactive drugs as a pedagogical tool? I know that.
Well, I didn't talk about psychedelics so much. For example, when often there would be a chapter in the biochemistry book on drugs, but so I mostly stuck to the opiates and the amphetamines and things like that because the students were more familiar with those names. So I remember one time I was teaching a bunch of students who were going to be elementary school teachers, and they just needed to know enough chemistry to know more than their students. Right? It wasn't going to be very complicated, but we came up with the story of opiates, and I told the story of the Opium Wars, and it was very interesting. Most of the students were, they were following me and nodding, but they didn't really get it. But there was this one Chinese student, and she knew all about it. So, no surprise there, right? And she was so glad to hear me confirm what her family had told her about their past, because they were from China. They were subjected to those wars. So I worked it in whenever I could, but I didn't really go into depth on the structure-activity relationships or anything like that.
Right, because even today, among professors who presumably do not have any personal experience with psychoactive drugs or psychedelics, I find that they are often introduced simply as a way to engage students because it's more fun to learn about a lithium aluminum hydride reduction or a Henry reaction or any number of different relevant chemical reactions if they're contextualized in the production of a psychoactive drug.
Yeah, but really, undergraduate chemistry classes don't usually get that far. I mean, you'll see a structure in the book. They'll be, you maybe put up the structure of LSD and ask them to find the indole ring or something like that. But some of the courses had a lab, but really making aspirin, a one-step synthesis, that's really the kind of stuff that was going on. Nothing complicated.
Did you ever make LSD yourself?
No, I never. Somebody gave me a small jar that they said had ergot in it, a brown powder. And I was thinking can I extract some lysergic acid from this? But no, I read the papers, and the best way to do it is you really need a laboratory because we're talking sulfur trioxide here, and that's it's very reactive, shall we say. It's not something you would find in most laboratories. And except for that first time in those first years, I didn't have a professor who would order anything I wanted. So we were depending on using chemicals that were already in the storeroom that had been ordered for other purposes.
Right. Yeah, that makes sense. And did you engage with the counterculture in Berkeley? Did you visit the Shulgins or anything like that?
I did go to Shulgin's office and talk to him for an hour and a half about a project I was thinking, people said, you need a research project to get tenure. I think, what am I going to do? And I finally thought that I would try to make a new cyclic compound and see if it had serotonin activity. Okay? And so basically take the STP molecule and that 2-methoxy group, if you join it to the side chain, so that carbon on the 2-methoxy group is also the alpha carbon on the amphetamine, then you have a benzene ring and a 6-membered ring with 1 oxygen in it. And it locks the molecule into a particular conformation. And so my question is does that bind better to the receptor or not so good? So I went to ask Hilgen, has anybody made this molecule before? Because I was thinking of making it. And he answered, no, it seemed interesting to him, but nobody had ever done it. I figured if anybody knew, he would. And so, I don't know, that was, when was it? I don't know, that was in the 80s sometime, I think. It was way after I did all of my work.
I don't think that those compounds have been made, these sort of saturated benzopyran compounds. I don't know that anyone has ever made those.
I haven't been able to find them in the literature. That's why they were interesting. It's not good research to make something that somebody else has already made.
That's right. But a lot of great work came out of that same idea of trying to conformationally constrain the methoxy groups. David E. Nichols at Purdue University produced.
Yes, but he used a all carbon chain or ring, and the reason, I think one of the reasons why he chose that, I don't know if he tried the other one and failed. It's not an easy synthesis to get that ring to be made.
He made the Dragonfly series. I don't know if you've seen those, that are the benzodifurans, but these are not constrained in the same way that you're describing. Instead of joining to what would be the alpha carbon in an amphetamine,
that's right. They tie the paramethyl group to the other methoxy,
or
something like that.
Yeah, the methoxy carbon is joined back to the ring, so that the 4 position is still open for substitution in the typical ways of the methyl or ethyl or bromine.
I see. It's tied up. Yeah. And if I remember correctly, none of those were particularly active.
Oh, no. The benzodifuran compounds are among the most potent known phenethylamines.
Oh, really?
Yeah.
Oh, well, maybe I'm thinking, wait, you mean the...
Imagine...
They're on the sides.
Imagine benzofuran, but then with difuran, with 2 of these 5-membered rings with an oxygen that are constraining the methoxy groups, and then the typical side chain with an amphetamine or phenethylamine side chain.
Okay, so the 2-methoxy comes back and holds on in the 3 position, and the 5-methoxy comes back and holds on in the 6 position.
Yes, exactly.
Okay, so I see. That points the lone pairs of the electrons in the proper direction.
That was the idea, yeah.
Uh-huh.
I still wonder about that, but that is the consensus at this time. It's one of those situations where some of the other potential structures that could further probe whether or not it is an issue of the orientation of the lone pair hasn't been done. But as things currently stand, that is the state of understanding. It's amazing after all these years how much of this phenethylamine pharmacology still is unexplored. I mean, it seems so simple. It seems so trivial, but brilliant chemists around the world working on this for 100 years, and there's still a lot left to be done.
Mm-hmm.
You couldn't get approval for that project, or why didn't you go through with it?
Oh, no. I couldn't get a teaching job. I continued it while I was teaching. I had use of a laboratory, and I, made some progress, but then the whole idea of my getting a tenured professorship became inoperative, and so I didn't pursue it anymore. One of the professors told me, he said, "We'd love to hire you for a permanent position, but here's how it works. administration gives us permission to hire a new professor. And so we put in an ad, and we get a bunch of resumes. Maybe a big stack of resumes, maybe like 6 inches high. And we're going to go through and separate out the resumes that aren't complete, and then we're going to go through the rest and decide who we're going to interview. And when we are doing this, the dean shows up. And the dean says, I sure hope there's some blacks and some women in that pile of applications. And we assure him that there are, and he goes away. And so then we're down to like 4 or 5 resumes, and we're going to ask the people to come in and be interviewed. And the dean shows up again. He says, I sure hope you're planning on interviewing some blacks and some women. And we assure him that that's so, and he goes away. So then we have our interviews, and we're ready to choose one, and the dean shows up and he says, hire the black, hire the woman. And so we do. But in those days, you could count the black PhDs in chemistry on one hand nationwide. There weren't that many of them. And guess what? They got jobs at Harvard with a $150,000 startup thing to get them going. And they didn't take the job at the California State University. They said, so we get stiffed by these guys. We don't know, they've all found better jobs at universities that will pay them more and support them more. And so we hire somebody like you, Tarek, for a year, and then we start all over the next year. We've been trying to hire a professor, a black professor, or a female professor for years, but we can't compete because Harvard and Yale pay more. And that was their dilemma. And so, I don't know, eventually there came a year where I didn't have any job. Usually I could move to a town, start the teaching job, and after I was there a couple of months, I had to start my job search for my next job. And then I would move in the summer and repeat. Well, there came a summer where I didn't have a job, and so I came back to the Bay Area and went into industry. That was the end of my college professor life. Not exactly. Later I did find a job at National Hispanic University in San Jose, and teaching the school teachers the basic chemistry and physics. But they went broke too, and closed.
Sounds like a hard life, like a lot of struggle. I mean, is there a reason you didn't want to just settle down and do research?
I wasn't that interested in spending my whole life in a laboratory. You know, it's if I was working with a team, then it would have been different. But really, the life of a bench organic chemist, it's pretty boring. You do the same thing over and over again. The hours are long. You know, the chemicals might be toxic. It's chemists don't have a whole lot of choice. They could work for a pharmaceutical company or an oil company, or maybe now an environmental company. You can't find a job in just any town as a chemist.
I mean, I certainly agree that the hours are long and the chemicals are toxic, but I think times are changing a little bit, and I'm in a especially interesting position where I get to make new psychedelic drugs above board at a university. And it's drawn a lot of really passionate students, and it's heartening to see people who are doing it not just because they want a degree or they want a paycheck, but because they're so excited by the opportunity to create these new things that now might even have the potential to become a therapeutic drug at some point.
Well, yeah, I saw just today that Australia, I think it was Australia, has legalized psilocybin and what was the other one? For therapeutic work. So I guess what that means is you got to go to a doctor to get it.
Yeah.
So, Tim Leary thought that people should get a license from the government before they took LSD. Tim Leary was a very straight guy in many ways.
I can't say I agree, of course, but I understand where he was coming from. There's always this tension between wanting freedom and an awareness that if bad things happen in the context of that freedom, there will be a crackdown of some kind. I'm also curious about what it was like working with Joe Nealons, because he's this legendary figure, and I find it fascinating that he worked with both you and Kari Mullis, both of whom had this involvement with psychedelic drugs and DET specifically. I don't know if you've read Kari Mullis's autobiography, but he dedicates a section of it to synthesizing DET, which he overdosed on and apparently took so much that he completely lost his identity for days, didn't know who he was or where he was or anything.
Oh. No, I haven't read that book.
Did you talk with Joe Nealons about psychedelic chemistry at all?
No, Joe, he wasn't enthusiastic about those things himself. He did mention to me that Kari came up with his idea. Did I mention this in the email?
Just in passing, but tell me the story.
He said, Kari. Well, Kari was in the lab a few years before I showed up, and he figured out one of the iron chelators, and he wrote up his thesis on that, and then he went off to do something else. I showed up, and I was doing similar work on a different iron chelator, but I referred to Kari's thesis for a lot of for guidance when I was doing my work. And at some point, while I was there, Kari got the Nobel Prize. I forget when it was awarded, but it was either just before or just after I graduated with my PhD, because I was visiting Joe even after I was out. So I'm not sure exactly when. But Joe said, Kari, he was riding his bicycle and tripping on LSD when the idea of the polymerase chain reaction occurred to him. And that's what he initially got the Nobel Prize for. And so Joe did mention psychedelics and Kari in that context. And when I was looking on the chemical shelves in Joe's lab, I did find some PMA derivative up on the shelf. And I wondered if Kari had something to do with that, but I never asked him about it. I only met Kari once or twice. And he was an interesting guy.
Certainly sounds like it. I just find it fascinating because I've heard a couple tidbits about Joe Nealons, and it seems like he was very permissive, very accepting of Kari's eccentricities. He knew that he was making LSD. He knew that he was using LSD and was okay with it, as far as I understand.
Well, I think so. He probably would have objected if it was going on in his laboratory, to where he could get in trouble. But yeah, Joe was very accepting of Kari and of me. I had my own oddities, and he never gave me any grief for it. Joe tried to help everybody. He was not. He wasn't the usual Berkeley professor in that way. He thought he had done well enough that he didn't need to, claim his graduate students' work. So he made sure that they got on the paper. So that's why I got one paper with my name first and Joe's second. And I was also on another paper where he was first. But he made sure that all of his graduate students got the appropriate, honors and credit for the work they did. And we agreed politically. We were both anti-war and stuff like that. So we got along very well.
Right. And how long has it been since you've engaged with the psychedelic world? Have you left that entirely behind you?
Oh, I still go to the library occasionally and see if there's anything new, less and less. It's harder to do now. Libraries are much more locked down now than they were when I was young. You can't just go into the stacks and find a volume yourself. You have to ask them for it. Things like that. Some of the stuff has now all been digitized and is behind a paywall. So you have to get a subscription or you can't go and use the library.
Well, there's a way around that now.
Oh.
Sci-Hub?
Really? You hacked the paywall now?
Well, there's a website called Sci-Hub, sci-hub.se, that allows you to access any scholarly article that has been digitized for free instantaneously. It's immensely useful.
Sci-Host, SCIHOST?
SCI-HUB.se.
Dot what?
SE.
SE?
SE, like selenium.
Huh. Well, haven't seen that extension before. I'll check it out.
It's really something else. I think the woman that created it has probably single-handedly made the biggest contribution to scientific research of almost anyone ever, because she has made every scientific article ever published freely available to anyone in the world. It's really an amazing resource. Yeah. Are there any other things about that era, about the experiments that you did, the compounds that you synthesized that you think people should know, or memories from that era that you'd want to share?
Well, let's see. One of the interesting things about my life was when, I'd get invited. These guys who were making drugs would invite me over. So, for example, I was, getting some scientific equipment, and I ran into a guy, and, we both looked like hippies. Well, we walked out of the building about the same time. He turns to me and he says, "Hey," says, "What? You know anything about making drugs?" I said, "Well, a little." He says, "We're having a terrible time over at the house. Would you come over and give us some advice?" And so I went over there and I find out they're trying to make amphetamine. These are a bunch of speed freaks. And it was scary. They were so hung up on getting high that they would try injecting the stuff before it was completely purified. That was their test, was IV injection. And I'm thinking, these guys aren't long for this world. And so they take, I think this was a methylbenzyl ketone and formamide kind of reaction. I think that's what they were doing. And And so they do the ether extraction, and the guy wants to shoot it up, and he decided that the rush he got was from the ether. And my face was on my palm, you know. I was thinking, oh my God, what is going on? So there was a lot of really crazy behavior going on. And, you know, these people, they didn't know any chemistry. But they could get the equipment and they could sort of follow instructions. And I thought it was amazing they weren't burning the house down, blowing themselves up. I guess just being able to talk about the psychedelics in a knowledgeable way opened up all of these doors for me. So I have a lot of stories in that regard.
And did you try to advise these people to behave differently, or what?
I begged them. I said, no, don't. You shouldn't be doing this. He said, oh, we've done it before. It's okay.
Huh. And this is in Berkeley?
No, that was actually in Seattle.
What about the clandestine psychedelic chemists, people like Nick Sand or Tim Scully or Owsley Stanley? Did you ever interact?
No, never ran into them. They were, I think by the time I settled in Berkeley, I was sort of passing through Berkeley a couple of times before I settled there. But I think by the time I settled, those guys were pretty much out of business. So I heard their names, but I'd never met them.
And did you ever contemplate doing something like that yourself?
No. I got two more stories where people tried to get me involved in this. One time, I mentioned that I had seen a synthesis for ecgonine, the center part of the cocaine molecule. And before I know it, there's this guy who's coming up to me and he says, hey, if you ever want to make a lot of money, all you have to do is make some cocaine for us. I know some people who will set you up with a lab and everything. Well, I immediately thought of the mafia and started to get worried. And so I didn't take that job. But because I wasn't even sure that the synthesis would work, and I didn't want the mafia angry at me. And I didn't want to be working for the mafia and all of that stuff. And so I declined, and he was disappointed, but I sent him away and refused. And then when I was working at my last teaching job, which was at the University of Nevada, Las Vegas, the teachers got the other professors got a message from somebody wanting them to make some Durovital. Have you heard of Durovital H3?
No.
Okay, it's not a psychedelic. It is procaine. Okay, the anesthetic.
Mm-hmm.
And the Durovital people make this procaine, and they sell it to old people who are in pain and things like that, and so it's supposed to make you young. The advertisement shows two couples, a young, healthy couple playing tennis, and an older couple also playing tennis. And the message is that this drug will let you compete with the young in physical things. If you look up the history of it, it comes from Romania, where the government decided that this should be made available to the workforce. So they had, for example, there was a factory that made light bulbs, and they hired a bunch of older women and men, but mostly women, to assemble the light bulbs. And they, being old, they were stiff and sometimes had trouble. And so they decided that they'd give their workers this procaine, and then that would reduce their stiffness, and they'd be able to work longer. And even more for the advantage for the government, the use of procaine gives you a heart attack, so you die, and they don't have to pay Social Security on you. So these guys were thinking that they ought to bring that to America. And they were already making the drug in Puerto Rico and trying to ship it into America, but they were having trouble with that. So they wanted to get a college professor to make a few kilos of that drug and sell it to them. And the professors, they saw this letter and they didn't want anything. So they said, oh, let's give it to Peterson. Maybe he's interested. So I got this letter, I look at it, I said, these professors, are they trying to get me in trouble? What's going on here? It didn't sound like on the up and up. And so I called the guy and wanted to talk to him, and he was trying to sell me on it. And I said, well, I don't know. He says, well, what's holding you up? I said, well, I don't want to go to jail. And he says, well, no, you won't go to jail. This is perfectly all right. Or something like that. And I was thinking, it's probably immoral because the stuff's going to kill people. And I don't believe him when he says that the feds aren't going to be upset if I make a bunch of this stuff and sell it to him. I think I could get in trouble for this. But it's amazing what offers a chemist gets in this department from people who want to make money off drugs.
Well, you described the frustration that you felt trying to get a job as a professor, and then at the same time, as you're going through this frustrating period, you have knowledge that could be used to produce very valuable compounds. I can imagine that it would be slightly tempting. Obviously, the examples that you just provided are all sort of frightening, maybe association with the mafia or doing unethical production of a compound that could hurt people or working with reckless addicts of one kind or another.
Mm-hmm.
But the temptation to make a psychedelic, which arguably has a positive effect on people.
There was some of that too. Like, I knew a lot of other graduate students, and several of them, when they were, ensconced in their graduate school, or even after they became professors, some of them were making small amounts of mescaline and a few other things. And so, yeah, there also were people who were doing it in real laboratories with due diligence and all of that. It wasn't all these crazies.
Right. And just out of curiosity, out of some of the other compounds you described, like MMDA or DMMDA, did you ever make those?
No, I got the oils, the myristicin oil and the parsley oil. I actually got those oils, but I never was able to nitrate them. There's one where you take the oil that it doesn't have the nitrogen on it, but it has the 3-carbon chain and the methoxy groups in the right positions. There are all of these different, they're basically flavoring from spices. And so the one for MMDA is myristicin from nutmeg. And if you move the double bond so it's conjugated to the ring, and then add tetranitromethane, you can put a nitro group on, and it's kind of like the aldehyde plus nitroethane, but it's another route. to that. And I never could get that first reaction to go. I got some yellow color, which indicated that it was sort of going, but I never got anything that crystallized. And so I never got any further than that.
The reaction with tetranitromethane was something that Shulgin did early in his career, but it subsequently became a sort of antiquated process. Now most people go from the phenylpropene to the ketone and then produce the amine via reductive amination.
Yeah, that's right. Well, and then the other problem is if you have a methylene dioxy group, it's easily broken. The compounds will be acid sensitive.
Right.
Oh.
Right. Yeah. Those are fascinating molecules. I've always been curious about them myself. The other one that you emphasize a bit is macromarine. Was that something that you ever extracted?
No. I'd heard about that. I suspect it's not very active, although it is the cactus is consumed. I understand.
And in terms of the tryptamines, you also describe the tetramethylene tryptamine with the pyrrolidine ring.
Yes.
Did you synthesize that by any chance?
Yes. It's I wouldn't recommend it. It's not worth anything.
Because when you have a 5-methoxy group on the ring of that compound, it becomes extraordinarily potent. It's a very potent 5-HT1A agonist and has been associated.
And not particularly pleasant. A lot of people get an intense fear reaction from it.
Well, there's passages in T-Call that describe people even going into a sort of dissociative fugue state from the 5-methoxy pyrrolidine tryptamine. It's been associated with some pretty wild reactions in users.
Yeah, I'm not surprised.
Yeah.
Some people they take a little bit of these tryptamines and their visual field kind of falls apart. They're looking at things and it looks like those things have separated into several objects that are sort of flying around independently. So I guess some people's brains are wired a little differently or something, but they're sometimes upset by what they see. Is I guess what I'm trying to say. They're not enjoying it.
Right. And are there any final stories about that period when you were making all these compounds you want to share about experiences that you had or things that you learned about the chemistry or even just the experience of using the compounds?
Well, I guess there's one story. I told you we eat the compounds and go wandering around on a Saturday, and there was one. It was the 246 TMA. We went out into the woods and we were walking around, and finally we're coming back to go eat at dinner at the cafeteria. And as we were walking up to the cafeteria, one of my friends said, "I'm feeling really confused." And when we got in where we were around lots of other people, we were all feeling really confused. So he said, "Oh, let's stay here. We're gonna go walk over to so-and-so's house." We start walking across town there. And one of the interesting effects was they were walking down the sidewalk, and then somebody would get an idea and say something, and everybody would stop and they'd be talking about it. And then they'd say, oh, that's right, we're supposed to be getting on. We'd start walking again, and we wouldn't get more than 30, 40 feet before it happened again. We were sort of confused. We weren't exactly thinking about our goals and moving toward them. We were just sort of floating. And we didn't know it, but one time we stopped and we were directly in front of the house of the chair of the chemistry department, who knew nothing about this. And he recognized us. He came out and invited us in for a beer. And somebody took him up on it. So four or five of us walked in and were entertained by the professor for about half an hour while we were looped. We were very confused. And again, he didn't notice a thing. Okay? But we felt like, I don't know, not quite trapped, but we didn't plan on this at all, right? And we didn't seem to be able to extract ourselves. So anyhow, after about half an hour, we did beg off and say we had a dinner to go to and left, and everything was okay. But I don't know, each of those compounds has its own special effects. They're not always interesting or, something that you'd want to repeat, but they all have their own individual things. And that one is toward the end of the trip, you can be very confused as to what you ought to be doing. It's easy for the mind to drift. The next day, we were perfectly normal.
That's really interesting. I've never used TMA6 or any of them, TMA2 or even TMA itself. I know that Shulgin had an infamously negative response to the 3-4-5 TMA.
Well, it's the dose is sort of high, and so you get this physical reaction, a clenched jaw, and muscle tension, and things like that. The early investigators misinterpreted that. They didn't take it themselves, right? So they fed it to the subject and then observed them, and they said that the subjects did not appear to be angry, but his body language showed intense anger, and they were worried that he might break out into homicidal violence. The investigators were actually scared of the subject because of the body language they were picking up. And I think it was mostly a clenched jaw and muscle tension and things like that. But it's all of the amphetamines have disadvantages like that. And it's mostly physical. I mean, they're not nearly as speedy as regular amphetamine, but it's there. It's there, and it's not always great.
And you tried the other TMAs, like the 3-4-5 TMA?
Let's see, 3-4-5, 2-4-5, and 2-4-6.
And do you remember any differences between them?
Well, the 3-4-5 was colorful like mescaline, but you had this clenched jaw problem. The 2-4-6 was that confusing one. The 2-4-5 was probably the best of the bunch. The dose was low enough that you didn't get any physical stuff, except that sometimes it takes a little longer to start up than most people are used to. They think 15, 20 minutes and you should feel something, right? Well, with these, it's more like 45 minutes or an hour, and some people would take a second dose, thinking that they hadn't taken enough. And then half an hour later, they realize that they've taken too much. Now, I don't think it was any life-threatening or anything like that, but it wasn't particularly pleasant.
Right. I think it was the apparent superiority and the increased potency of the 2-4-5 TMA2 that made Shulgin focus so much of his work on that substitution pattern.
Yes. And then I think the first thing they did was make the 4-methoxy-ethoxy, and they found out that that improved things, and they keep on increasing it, and it keeps on getting better for a while.
And what about psilocybin or psilocin? Did you ever attempt any of those?
No. The problem with that is getting that oxygen on that position of the ring is not easy at all.
Typically, people start with the substituted indole, like 4-benzyloxy-indole or 4-acetoxy-indole.
That's right. If you can get something like that, then it'd be pretty good. But the question is, how close can you get to the final product with starting materials?
Right. So nobody was using psilocybin during that era, I assume.
No, I didn't run into any psilocybin mushrooms until I think it was the 1980s.
Right. And out of curiosity, who was the undergraduate chemistry professor who was so supportive of your work? Sounds like a great guy.
Oh, I don't know. He's passed on now. All those guys are gone.
Yeah. It's wonderful that you had that opportunity. Yeah. I couldn't have come up with anything better if I had been trying to do it myself. It was like I just sort of showed up, and everybody else wanted these things to happen. But that was one of the rewarding things. I mean, I felt like I was doing a social good in the work. Yeah, no, I think you were. And I really appreciate that you took the time to speak with me and answer these questions. And I appreciate that you wrote this book. I guess just was not widely circulated, so people weren't aware of it, which is a shame because it's so much better than almost anything else that was released. Well, it certainly was different because I was trying to educate them on the structure-activity relationships and on all of the odd chemicals that are already out there, but were unknown to most people. So it was that, I think I quoted 3 papers. There were 2 of them were, hallucinogenic plants and hallucinogens of plant origin. Those were papers in a journal. And then there was that book, Ethnopharmacologic Search for Psychoactive Drugs. I got that one from the government printing office for $5. That's amazing. Yeah, they're legendary books at this period. And you don't, I think you already mentioned this, but you don't even have a copy of The Alchemist yourself. I don't, I'm not sure. I've got a box of old notes and it might be in there, but I kind of think I don't. Well, if you ever dig up some old copies, let me know. I have a sort of archive of this kind of literature, and I'd love to preserve it for posterity. Although there is the copy at Harvard. Yeah, somebody should do a better job of scanning it. Yeah. And do you object to me sharing that scanned copy other than the issues with the quality of the scan? Oh, no. I mean, you can read it. It just makes it a little more difficult but everything's in there. I don't mind. Yeah, I appreciate that. And if you ever think of anything from that era or any interesting memories, call or email me anytime. I'd love to talk. Okay. All right. I looked you up on Wiki, and I'll read some of those things. I wasn't aware of your work. It's fine, yeah. But I'm fascinated by this whole world, and talking to people like you, I think, is really valuable, especially as the world of psychedelics becomes increasingly mainstream and medicalized, I think it's important to remember where things were not so long ago and the sorts of work people were doing in the 60s and 70s.
Yes. I don't think people understand the attitudes that were prevalent back then. It was a whole different time.
Yeah. So it's valuable, and I'm glad that I was able to track you down. So thanks again for your time and being so forthcoming with these stories. And I hope you have a great night.
Okay. You too.
Okay. All right.
Hey.
Bye.
Good night.